Okay, class, Assalamualaikum and very good evening to all of you. Welcome back to the class. Today, in this exercise, I will start with exercise number 6, which is related to the topic of design of main reinforcement or flexural reinforcement for beam with which considering flange. Okay, let me share my screen. Okay, so in exercise 6, okay, this exercise will be strongly related to the example 1.5 in the module. So I give you a simple example here, and I hope you can do it. Okay, for our first example is exercise number 6. So I give you a simple beam, okay, T beam, which is the beam with flange, and the value of here is your B, here is your HF, here is your D. Okay, this is your BW. Okay, and then so this is the value of B is equal to 600 mm. HF, okay, the thickness of slab is equal to 150 mm. D is equal to 400 mm. BW is equal to 200 mm. FCK, we have 25 Newton per millimeter square, and FYK, we use steel with 500 Newton millimeter square, and then the MED is given as 300 kilonewton meter. Okay, this in this case the MED, the design moment is given. If the design moment is not given, you can calculate by yourself. Let's say for simply supported beam, the MED, okay, the simply supported beam, MED can be calculated by using these equations, WL over 2. Okay, this is W and this is the L, the span of the beam, and the VED, the shear force, design shear force is equal to W. Oh, sorry, this one is WL square over 8. Okay, WL square over 8, and WL over 2 is for the shear force. Okay, and then in this example, the D is given. Okay, the D is given here. Okay, which if the D is not given, you have to determine yourself. Okay, let's say for this, okay, let's say we have at the mid span, since the tension is occurred at the bottom, so our D we calculate. Okay, let's say here this is our okay, make it simple. Let's say this is a rectangular section. Okay, consider it rectangular section. This is our section. So at the mid span, so where is our H? Our H is here. Okay, here is our H. Okay, this is simple. This is our H. From top surface to the bottom surface of the beam. This is our H. So this is our, let's say, our main reinforcement. This is our AS prime. Okay, and this is our AS. Okay. Usually the diameter of AS and diameter of AS prime is not similar. Okay. AS, here is AS prime. I hope you can see my screen. Okay, and then we have our still our link here. Let's say this is our link. Okay, okay, good. This is the diameter of our link. Okay, here for me is too large. Sorry, the link is too large here for me. Okay, I reduce the size. Okay, maybe here. Okay, this one. Okay, this is our link. Okay, we enclose the top and bottom reinforcement. So, for our case here, this is our D. Okay, because our D is measured from the top surface of the top surface of the beam to the center of steel reinforcement. Okay, for the center of S. This is our D. So, in order to determine the value of D, you must okay, this is a very basic okay, this is the C nominal. Sorry, C nominal, and then this one is the diameter of the diameter of link, and this is here a very small portion is diameter of main bar over 2. So the D we can measure simply as equal to H minus C nominal minus diameter of link, and then minus diameter of main bar over 2. Okay, and then the D prime, for the case of midspan, the D prime is from the top surface of the beam until the center of the steel provided for compressions. So it's similar. We have the here to here, we have the C nominal, and then we have the diameter of link, and then we have the diameter of main bar for AS divided by 2. So the D, the value of D is equal to C nominal plus diameter of link plus diameter of main bar over 2. This is a very simple concept that you must understand. However, for the case of let's say for the case of at support, okay, near the support of for cantilever, the situation, okay, is inverted. Okay, the shape is like this one. Okay, this is the beam. So the AS prime is located at the bottom. Okay, because the compression is at the bottom, and the tension at the top, so AS prime is at the top. Okay, this is AS for tension. For tension, yes. So this one is your link is here. So your D is measured. Okay, this is your H. Your H is still standard, still similar. Your H. Your D is measured now from the, okay, this is the center, from bottom part. Okay, from bottom to the top. This is your D. And then the D prime is here. This is your D prime. Okay, however, the formula is still similar. Okay, but the position is differ. Okay, so for our case, D is given, so you don't have to worry. But for this one, this is strongly related, just like exercise number 7, as you did. Okay, the solution for this one is, first we have to check the MF, where MF is equal to MF equal to 0.567 FCK times BHF times the D minus HF over 2. Okay, and then equal to 0.567 FCK is equal to 25. Our B is equal to 600. Okay, and then The flange is 150, and then D is given as 400 minus 150 over 2. Okay, what is our value of MF now? Anybody have the answer? Okay, what is our MF? Class, can you hear me?
For 1.5 kilonewton meter.
Okay, good. 415 kilonewton meter. Okay, so as we learn here in our lesson before, if the this one I open the, it's okay. Week number 4. This is the notes. Okay. Okay, you refer back to these notes. Okay, as you did in exercise 7. Okay, the MED is okay. This one. Okay, this one. Okay, because the MED is greater, if the MED is greater than the MF, so the neutral axis lies below the flange, so you must design by considering the flange. However, if the MED is lesser than the MF, it means that the neutral axis is in the flange. So the flange is not effective to cater for compressions. So we just design directly for rectangular section. So as our exercise here, this one is greater than the MED. MED is 300 kilonewton meter. So this is this one okay, greater than MED. So the neutral axis in flange. So we directly design for rectangular section. So what is the step to design for rectangular section? Okay, you recall back your exercise number 2, if I'm not mistaken, number 2 until number 3, 2 and 4. Okay, either you need the single reinforcement or double reinforcement. So you must check the value of K, which is equal to M over BD square times FCK equal to 300 times 10 to the power of 6 divided by B is equal to, use our B of, the B is, now our B is equal to this one. Our B is, we use, okay, this, okay, BW, okay, because we want to design for the rectangular section, okay. So we use our B equal to 200. Okay, 200 times 400 square times FCK 25. Okay, what is the value of K now?
Kosong 375.
Okay, 0.375 mm. So we need, this is double reinforced or singly reinforced?
Double.
Double reinforced because
Modern cable.
Okay, more than cables. Okay, more than 0.167. Okay, so it's doubly reinforced. Okay, so we can okay, let's say just Z is equal to okay 0.5. Okay, D here is D. Sorry, D 0.5 plus 1 0.25 0.25 minus cables divided by 1.134 equal to D 0.5 plus 0.25 minus 0.167 divided by 1.134. So what is the value of Z now?
0.82.
Okay, always 0.82 D. Okay, so let's say that 0.85. We use a 0.82 as our Z. So now our D prime, okay, let's say D prime is given, okay, I just give you the D prime. Let's say D prime is 50, okay. Let's say D prime is 50 mm. Okay, but if you use here that's why in the module, okay, in the module, the design is K equal to lies in a flange. If the neutral axis lies in flange, so we shall design by rectangular sections. So the B, we shall use the B of this one. Okay, actually B equal to 200, not 800. Okay, not 800. Okay, so you, okay, please don't be confused. If you want to use if we design for rectangular section, if the first we check the MF first. Okay, MF, if the MF is greater than MED, so we design for rectangular sections. So the B is for rectangular only. Okay, the width of the beam itself. Okay, so the D prime is equal to 50 mm. Okay, so the equation shall be, okay, sorry, I have to refer. So week number 3, this dot. Okay, solution. Okay, this one, you refer to example number 3, exercise number 3. Okay, the AS required here, this one. As required is equal to S required, S prime, S prime required is equal to K minus K balance, K balance, FCK B D square divided by 0.87 FYK B minus, D minus D prime. So it's equal to, our K is, okay, 0.375. 0.375 minus 0.167 times 25 times 200 of our, and then 400 square divided by 0.87 FYK is 500. Okay, what is the answer here? Okay, any answer? What is the AS prime required?
1093.
Macam besar 1093 mm square. So Okay, let's say we use so this one kalau 101093, let's say macam ni lah kot. Okay, 1093, so 126, so 4H20 4H20, let's say 4H20, we use 4H20. Okay, AS prime is equal to 1260 mm square. Okay. Okay, next. So okay, let's say class, if the diameter of reinforcement, okay, let's say the diameter of main is given as 20 mm, and you use 20 mm to calculate the value of D and so on. So you must select only from 20. Okay, how many numbers? It doesn't matter. So you must refer to diameter 20 only. Okay, but in the okay, let's say in the test or in the exam, if the diameter is given as 16, so you must select only from 16. Okay. Memanglah kadang dia betul juga kalau you pilih satu part 9770 ni pun betul juga, ini pun betul juga. Tapi kalau but in the exam, if you are given that the diameter is 20, so you must refer only the area for bar size of 20 mm. Okay. So now you calculate the D prime minus D, 50 minus 400 equal to 0.125 lesser than 0.171. So the compression still has yielded. So you may refer to this. Okay, let this notes again. Okay, analysis of this one is flange. Sorry class. Okay. Okay, refer to this one. Yielded. Okay, this one. If the D, okay, if the D prime over D is lesser than 0.171, you may use these equations to calculate the AS. However, if the D prime over D is greater than 0.171, you must use these equations to calculate the AS. Okay, so be careful of this ratio. Okay, so now since our AS is our ratio of D over D, D prime over D is lesser than 0.171, we may use to these equations. Okay, AS is equal to K balance times FCK times BD square divided by 0.87 FYK times Z balance plus AS prime, so equal to 0.167 times 25 times 200 times 400 square divided by 0.87 times 500 times Z balance is equal to 0.82D. So 0.82 times 400. Okay, because our D is given as 400. And we plus the AS prime, which is 1093. Okay, here 1093. The required value, okay, the required, not the provided, 1093. So any answer for this one? Any answer?
Two zero two nine.
2029. Okay. Okay. Sekejap. Okay. 2029. Okay. 2029. Okay. Dia ada point-point kan? But it's okay lah. You just round up to the nearest. Okay. square. So use. Okay. Which one to use? Okay. Let's say you want to use 2029. So 5. Okay. 5H25. Okay. Or 7H20. But lah. Okay. 5H25. Let's say use 5H25. But in the exam or in the exam or in the 24 something, in the exam or in the test, if you are asked to use diameter, let's say diameter 20 or 25, you just refer to the data from diameter 25 only, and then you select the number. Okay. And then once you got your AS, you can check the AS minimum and check the AS maximum. Okay, make sure that both two is okay. Okay, you must check. Okay, this one I leave it to you. You I believe you know how to check. Okay. Any questions? Any question, class?
No question, Doctor.
Okay, thank you. I hope you can do it. Okay, thank you very much for your attention.